You're all welcome once again to Ojibra Academy channel. And on this video, we'll be looking at how to balance redox reaction. Redox reaction can be balanced in two different medium. We have the acidic medium and the basic medium. So you can balance in any of these two mediums. Now, redox reaction is different from other normal chemical equation where you are going to be balancing the number of atoms at the reactant side and compared to what you have at the product side. For redox reaction, we're going to be having charges. You have charges, so it means it has a different way of balancing and approach. We have set of rules for balancing redox reaction, which number one of the rule is balance all atoms other than hydrogen and oxygen. Then number two is that you balance oxygen with appropriate number of H2O, balancing oxygen with appropriate number of H2O. And number three, we balance hydrogen with appropriate number of H+. Number three, we balance charges with appropriate number of electron. And the last one, which is number five, we are adding appropriate number of hydroxyl, which is OH minus, to every H plus present. Now, you discover that at the front of rule 5, I put basic. That means if you are balancing in basic medium, that is when number 5 is important. If you are to balance in acidic medium, you are stopping at rule number 4. So we're going to be applying these rules to balance the equation above, which is Cr2O72 minus plus Fe2 plus to give Cr3 plus Fe3 plus. The first thing I will advise is for us to break the equation into two. We break the equation into two. We have that of Cr2O72 minus to give Cr3 plus. Then the other part is Fe2 plus to give Fe3 plus. Now we've successfully broke the equation into two now, because normally it is Cr2O72 minus that will produce Cr3 plus, and from Fe2 plus to Fe3 plus. So each of the equation will now be balanced using this set of rules. Now, rule number 1 is saying we should balance all atoms other than hydrogen and oxygen. It means while we balance all atoms, we're not going to be balancing oxygen, we're not going to be balancing hydrogen. So for this first equation now, we have 2 chromium at the reactant side here. We have 1 chromium at the product side. So to balance chromium now, we add 2 to the back here. Chromium is balanced. So 2 chromium at the reactant side, 2 chromium at the product side. Remember, we are balancing other atoms except oxygen and hydrogen. So we're not going to be touching oxygen yet. Now, for the second equation, we have ion, 1 ion at the reactant side, 1 ion at the product side. These are charges. We are not touching them yet. We are only balancing atoms. So we have done number 1. Number 2, balance oxygen with appropriate number of H2O. Now, if you check this first equation, we have 7 oxygen at the reactant side. So we're going to be adding 7 molecules of water to the product side to balance oxygen. So we have 7 oxygen here, we have 7 oxygen here as well. Now oxygen is balanced. For the second equation, we don't have oxygen, so we don't have to touch it. Now we go to this third rule, balance hydrogen with appropriate number of H+. That is what the third rule is saying. So as we added water to the product side, we're automatically adding or introducing hydrogen. So at the product side here now, here where we have water, we have 14 hydrogen put together, and we're balancing hydrogen with H+. So to the reactant side, we are adding 14 H+ plus what we have there already. So it means hydrogen is balanced. We have 14 hydrogen, everything is balanced. To the other equation, we don't have hydrogen, we don't have oxygen, we don't have to touch it. So the next one is balance charges with appropriate number of electrons. That's rule 4. Balance charges with appropriate number of electrons. Now, your charges, you are going to be multiplying the charge you have on that molecule with its coefficient. So it means for hydrogen alone, we have plus 14. Plus 14 for hydrogen alone. Plus 14. For chromium and oxygen, everything together here, we have minus 2. So the total charge at the reactant side of this first equation is plus 14 minus 2, which is going to give us plus 12 all together at the reactant side. Now going to the product side, for chromium here, we have plus 3 as the charge, but we have 2 at the back. So we multiply, we have plus 6. For chromium, we have plus 6. For water, is a neutral compound, so it is 0. So plus 12 at the reactant side, plus 6 at the product side is not balanced. So it means we have to subtract 6 from this 12 so that it balances with the 6 at the product side. So we are going to rewrite everything here now. We have Cr2O7 2 minus plus 14H plus 6E minus to give 2Cr3 plus 7H2O. So the total charge is balanced now. Minus 2 plus 14 minus 6. It gives us plus 6, and we have plus 6 at the product side. Balanced. Now let's balance charge for the second equation. Fe2 plus to give Fe3 plus. So for iron here is plus 2. For iron here it is plus 3. So we are subtracting 1 electron from here so that it goes to balance with plus 2 here. We have added electron to the reactant side of the first equation. So we should be adding electron to the product side of the second equation so that they will be at different sides in the two equations. So we're adding plus E minus to this. Now charges are balanced. But if you look at the two equations, number of electron here is 6, number of electron here is 1. Number of electron is not balanced, and it should be balanced. So we multiply the O equation here by 6. We multiply the O equation here by 1 so that everything goes to the same thing. We are doing this so that number electron will be the same. So if you multiply this equation by 1, it remains the same. If you multiply this equation by 6, you have 6Fe2 plus, 6Fe3 plus, and 6, let's change this to 6E minus. Number of electrons is now the same in the two equations. Now, the next thing is for you to rule out whatever you have at the reactant side of one equation, and you have that same thing at the product side of the other equation. For instance, we have electron at the reactant side of this equation 1. We have electron at the product side of this equation 2. They can cancel out. Electron cancel electron. Do we have anything else? No. Then we can combine the two equations now by saying that we have Cr2O7 2 minus plus 14H plus to give, we have this at the reactant side of the second equation. We are combining the two equations. Plus 6Fe2 plus, we have written everything at the reactant side of the two equations. So we are going to the product side now to give 2Cr3 plus 6Fe3 plus 7H2O. Equation is balanced now. If you check properly, we have 2 chromium at the reactant side here, 2 chromium at the product side here, 14 hydrogen at the reactant side here, 14 hydrogen at the product side, 6 iron at the reactant side, 6 iron at the product side. Let's check our charges. The total charge, or the total charges at the reactant side, we have minus 2 plus 14 plus 12. So it makes it plus 24 if we check properly. The total charge at the reactant side, minus 2 plus 14 plus 12 will give you plus 24. If you look at the product side, we have plus 6 from chromium and we have plus 18 from iron. So it also makes it plus 24. So everything is balanced. Now this reaction has been balanced at acidic medium. Acidic medium. If we check, we have H plus, which signifies acidity. So it means this reaction is at acidic medium now. If we are to take to basic medium, that means we are going to be adding OH to everywhere you have H plus. Thank you.